Okay, hello everyone. So I am gone today for some district meeting, and so today I'm going to be kind of making this video to walk you through the one of our really our last topic before our quiz, which is applications of trig functions. So basically, in word problems, how do we use trig functions and apply them to situations that we might see in real life? So one thing that to note is that there's two main types of applications, right? Trigonometry is based around triangles, and so there are two main types of problems we're going to see here. One is an angle of elevation, and what I mean by that is, let's say you are like there's some level ground area, and basically we are looking up or something is pointing up, right? That is an angle of elevation, right? So the angle of elevation would be right there. That is theta, the angle of elevation. Okay, so it's basically like you're looking up. Okay, so there's an angle going up, from the bottom up. So imagine this is being tilted that way. That's like the angle of elevation. That's pretty straightforward. It acts like a pretty typical triangle we would have. However, another one we can have is the angle of depression, right? And so that would be, right, if you were, let's say, on top of a cliff or a mountain or something and you look down, that angle you're looking down, that is the angle of depression. However, the angle is not right there. That is actually not where the angle of depression is. The angle of depression, if you originally were looking straight like this, and now you're looking down, this part outside of the triangle is the angle of depression, right? But one thing to note about all these problems is, luckily, if you remember from IAG, if this line right here and this line right here are parallel and they're cut by a transversal, then opposite interior angles are congruent, which means these two alternate interior angles, those are congruent. So really, when you're trying to find the angle of depression, you can really just find the angle, the alternate interior angle there, and you can evaluate that instead, and you're getting the same answer, okay? That's one thing to know about angle of depression. Gets mixed up a lot. It's not this angle right here at the top. It is the angle outside looking down, but you can also use the alternate interior angle to evaluate, okay? So I'm going to do a couple examples with you, okay? And yeah, okay? So for this one, please note that if you're going to use a calculator at some point, you will need to be in degrees, okay? But we'll talk about that in just a moment, okay? So a skateboard ramp rises at an angle of 16.5 degrees and is 20 feet long. So we have a skateboard ramp. It is 20 feet long. Sorry, the ramp is 20 feet long. Okay, and the angle is 16.5 degrees. Okay, so the ramp itself is 20 feet long, and the angle is 16.5 degrees. And so at what height is our little skater going to be at? So this is what we want to know right here, what that x value is as he leaves the top of the ramp. So basically, we're finding the side opposite of the angle, okay? So again, I would think to yourself, what angle includes the side opposite, O, of an angle? And what side includes the hypotenuse of a triangle, right? What includes the side opposite and hypotenuse? That would be sine. So we can set up a sine function to evaluate for x. So the sine of 16.5 degrees is equal to our opposite side x over 20. And so if we want to find what x is, we just got to cancel out this 20 right here. The opposite of dividing by 20 is multiplying by 20. So we cancel it over here. So x is equal to 20 times the sine of 16.5. So what I'm going to do is now, we'll take a second to write that down if you need to. You can pause right here. I'm going to go to my calculator on my iPad. Okay. So, oh, that's the key. Never mind. Sorry, there we go. Okay. So, I'm going to do 20 times the sine of 16.5. Sorry, 20 times the sine of 16.5. And then before I hit enter, I'm just going to go and check. I am in degrees. Yes, I am. So about 5.68, and what unit are we talking about? 5.68, where's notability? All right, we're back. So x is about 5.68 feet, because the unit we're talking about here is feet. And that's the whole problem, okay? So you're basically setting up a trig function and then solving for the missing variable by using the ratio that the trig function has, right? So if it's sine, you'll use opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent, okay? That's the first problem. So pause right here, take a second to write it down, and then move on to the next one. Okay, so that first one was a little bit of it was an angle of elevation. There's an elevation up on the ramp. So now we're going to focus on a depression, or an angle of depression, yes, so going down. So Anaya wants to create a bridge between her house and her neighbor's house. Anaya's bedroom is on the second floor. Okay, so let's say these are the two houses. Very tall, skinny houses. Okay, let's make this Anaya's house. Okay, and let's make this house over here her neighbor's house. Okay, so Anaya wants to create a bridge between her house and her neighbor's house. Anaya's bedroom's on the second floor and looks down at the neighbor's first floor at an angle of 30 degrees. The houses are 35 feet apart. Okay. So part of my not very flat ground, but let's just imagine it's flat. Okay. And she's on the second floor and she is looking down at her neighbor's first floor. I know it's going to the ground, but for the sake of the image, we're going to just make so it looks like a triangle. We're going to draw it going down. And so if she was originally looking straight forward here, she is now looking down at an angle of 40 degrees. This is the right triangle. How long does the bridge need to be? So it's asking for this length right here in green, right? So how long does this bridge need to be to draw a bridge between her house and her neighbor's house next door? Okay, so what they're asking for is this bridge that goes from the first floor to the second floor, or the second floor to the first floor of the other house. How long does that have to be? So what we're given is, we're given the angle of 40 degrees. Okay, however, that angle isn't very helpful to us because it's outside of the triangle. But remember, these lines right here are parallel lines, and if they're cut by a transversal, that means that the alternate interior angle right here is also 40 degrees. So we can just use that instead. Okay, so now we know that we have a 90-degree right triangle with 40-degree angle in the bottom, okay? And so we want to find the hypotenuse x. So we are given the adjacent side to the angle, 35, and we're also looking for the hypotenuse. What has adjacent and hypotenuse in it? Cosine. So we're going to set up a cosine function using the angle 40 and the side of 35. So the cosine of 40 degrees is equal to adjacent 35 over x. Okay, and now all we have to do is solve for x, okay? So the easiest thing to do first is let's get the x out of the denominator by simply just multiplying by x on both sides, because that'll cancel it out here, and we'll just move the x to on the left side. Okay, that's you want to kind of get the x out of the denominator first, makes it a little bit easier. And then last thing, how do we get x by itself? Well, we have this number here, cosine of 40. Let's just divide by that, because if we're multiplying by cosine of 40 and then we divide by it, it will cancel out. So x is equal to 35 divided by the cosine of 40. So if I go to my calculator and I do 35 divided by the cosine of 40 degrees, I get 45 point, does it ask for nearest foot? It doesn't, so we're just gonna round to two decimal places. 45.69 feet. Right, 49.69, that makes sense? 45, sorry, 45.69. There we go. Boom. Okay. So this is referring to missing angle side. So again, in the first problem, we have an angle of elevation. We're going up, we're looking up at an angle, and we're setting up a trig function to solve for x. Here, we have an angle of depression, and we use the alternate interior angle instead to find the missing angle. or the missing side, and we set up another trig function. So that's the angle of depression. Now, these were both missing sides. So one thing I'm going to leave you with, because we will continue this after the quiz that you will have tomorrow, okay, which will not have this on it. It will not have inverse trig functions on it. It'll just be targets 1 through 4, that organizer. But I want you to think about, if you have a triangle, and let's say you don't know what theta is, but you do know the side opposite to theta is 3, and the side adjacent to theta is, let's say, 10, right? So you know the sine of theta is equal to 3 over 10, right? I want you to think about, knowing what we know now, and hint, this has happened very recently, what do you think we might do so we just get theta by itself and we can evaluate what theta is? How do we cancel out this sine part right there? Okay, and so think about that, because we'll continue with some stuff, with some of that. Okay, and I will actually start off with I'll actually start off with kind of evaluating this, which only takes, we have one more step to do after this actually, so it's almost done. I'm sure most of you could figure it out. Okay, so one thing to think about that for solving for angles. All right, that's everything. Okay, so let me know if you have any questions. Tomorrow we'll have our quiz on targets 1 through 4, so that's pretty much like the unit circle, coterminal, reference angle, SOHCAHTOA, all that stuff, and then inverse trig functions, and this applications will not be on the quiz, but it will be on the quest next week. Okay? All right. Thanks, everyone. Have a great day.